doing all the X prime X inverse matrices by yourself.
Yeah. No, that kind of technology I like.
It's been around for 30 years, it's all right.
If they watch the video, they're not going to be able to hear you talk at all.
Oh, they'll hear it. It just uses the
Okay.
microphone on the phone. They won't hear it as well. So, let me get logged on to the SAS server. And while I'm doing that, let's remember what we were in the middle of doing. We were trying to go through section 11.2, which was a case study. You remember what the scenario was for that case study?
GPAs and SAT scores.
Right, GPAs and SAT scores. So let me find the, here it is. So I have trouble with the technology here, getting it copied out while I'm in class and running it. So I prepared in advance some PowerPoints that capture the SAS windows, all right? And I've also been having trouble, as some of you have said, that you've had trouble copying and pasting out of SAS and into Word or into Excel or whatever. And what I have found is probably as easy as anything is open the Paint program, right, which is on the WooStat server. So you click on the Start button, you go to All Programs, and then Accessories, and then Paint. Right? So it's all in there. And this is the Paint program with an image of the screen captured and pasted into it. Right? Yeah.
And if you click the scissors at the very top, like if you're using a Mac, it'll copy it and then you can paste it into. You can't do Control-C.
So same kind of thing.
Yeah.
But it's different on a Mac. The buttons are different. But do you have a comment?
If you're on Windows, you use the stick tool to do that in a couple less steps.
Yeah.
It just pulls out the window and I'll make a picture of it.
Yeah, but will it do it on this server?
Yeah, there's a stick tool on the server.
Oh.
All Windows operating systems come with
And
that.
See, this is an old version of Windows, so I didn't think that it had that. So anyway, capture it as an image, and then you can paste it into a Word document or into Excel. It'll go in as an image. You can't edit it, but that's good enough for what we're doing. Okay. So let me get out of that, and so predictors of GPA. First step you're going to do if you're going to use SAS Enterprise Guide is to import the data. You're used to that by now, so you know how to get data into it, right? It'll be in an Excel spreadsheet, and then you click the Tasks button, then you go to Regression, and then Linear Regression. So I've also got that up and running, so let me switch over to SAS. This is showing a code window, so don't worry about what's on the screen. But up here, I've loaded the data in as a spreadsheet in my process flow. But then if you click the Tasks button, then you see Regression. So you click on Regression, and then you have Linear Regression. Now, since this is multiple regression, and this is why I gave you that little speech last time about multivariate analysis versus multiple regression. Multivariate is the next word under regression. If you click that, you see correlations, which you will need to get a correlation matrix, right? So you'll need that, but that's also, I think that's also available somewhere else under describe maybe. But otherwise, you don't see anything you recognize. You see weird stuff. Canonical correlation, principal components. That's all multivariate analysis. It's not what you need. So click on regression, then go to linear regression, and then you get this regression window pop-up. Right? So, slide that over a little bit. To do a multiple regression analysis, let's just do first of all, a single variable. Up here it says data, and it's got the data window open. So while that's open, you click on your dependent variable, that's GPA, and then you can hit this arrow, or you can drag it over and drop it under dependent variable. If you just hit the arrow, it'll ask you, well, okay, where do you want to put it? And I want to put it in my dependent variable. So then it drops it there. Right? So this should be familiar. So let's start with high school math score. Drop it over as an explanatory variable. And then I'm just going to hit run. And after it thinks for a while, what we're going to get is a single variable high school math. And the reason I want to do this is because I want to compare what happens when you have one variable in the model, and then when you add another variable, what happens to the test of that variable. Right? So for right now, one variable, high school math, is it a good predictor of college GPA?
Not really.
Looks like it's highly statistically significant. Right? What are we testing here? What does this p-value, what's the null hypothesis for that p-value?
That there is no linear relationship.
That there's no linear relationship between your high school math grade and your GPA in college. Right? This says reject that. So there is a linear relationship. Now in terms of symbols, what's the null hypothesis?
Each
Beta 1 is
slope.
Yeah. H naught colon beta 1 equals 0. Right? So that's the slope parameter is equal to 0. So this says the slope isn't 0. But that doesn't say that it's a steep slope. It just isn't 0. Right? This is also a test for the correlation is 0. So there is a correlation. It may not be huge in terms of what we think is a big correlation, but at least we know it isn't 0. Taylor?
So like when you ask, is it a good, maybe I was misunderstanding, a good model. So if you were to put random data in, you may get a 0.1 R squared. So
Okay, so Taylor has already had regression class, so he's kind of trained to think, and that's where I wanted to go next. This says it is a highly significant predictor, but look at the R squared.
It's really low.
What does that number mean again? 0.1762.
percent of the variance.
So 17.6% of the variability in college GPA can be explained by your high school math grade, which means 83% cannot be explained by that variable. So sometimes you get highly significant results, but if you look at the R squared, it's still not that great of a variable, right? So there's this balancing act, and it's really an art form of what we call model building. So let's go in and put the other two high school grades into the model and see what happens. Right? So I'm going to modify task, and I'm going to add high school science and high school English, and does it not let me?
Yeah, it's like the arrow again.
Yeah, I'll put them in one at a time. So explanatory variable. If I had my mouse, you can hold the control button down and click, and you can select all 6 at once or whatever. But this side. So then high school English, put that in there as an explanatory variable. So now I have GPA as dependent, and then the 3 high school grades as my independent variables, and we'll run that. No, I don't want to replace it because I want to go back and look at the other one also. Okay, so here's the one that we saw before, and as soon as it gets done thinking, it'll pop this one up. I hope it will. So yeah, look at R squared. it went from 17% to 23%. It was about 18%. So it went up by 5%. It's not huge, but you know, GPA is a hard thing to predict. So there's a lot of random noise in there. Look what happened with the test statistics here.
So English.
English is worthless.
Yeah, English is worthless.
English is not, you guys use the word worthless. It's definitely not a significant predictor. Now, what did I say last time about these tests? Each is tested after what? After the other variables are in. So they're all last variables added last test. So what this says is that high school math is now 0.026, whereas before the p-value was less than 0.0001. And now it's 0.026. And neither of the other two are significant, although high school science is really close. It's borderline 0.05 something something. Right? So each of these is then interpreted after you control, or after you explain all the variability that math and science can explain, then knowing your English grade doesn't help. Now what if I go back and refit the model with only English in it? What do you think will happen?
It's probably going to be significant.
Okay, probably will be significant. Question?
Is that what you were talking about when you said the last class that when everything has been explained by something else, then this other thing doesn't have a lot left to contribute, and therefore...
Exactly.
Okay.
That's exactly what we're getting at here. So let's modify task. Let's take high school science back out of the model and high school math out of the model and run only high school English. So remember, it's t-value, not just the p. So its t-value is 0.89 and its p-value is 0.37. Now its t-value is 4.68, right? And the p-value is tiny, tiny. Right? So remember the correlation matrix that I showed you last time? We have a high correlation between all those high school grades. So if they're highly correlated with each other, then when you use one of them to predict y, and then a different one to predict y after first explaining everything you can with the first one, since they're correlated, there may not be that much left to explain. So the 0.37 doesn't say English is not a good predictor. It says after you know their math score and their science score, you don't really need the English score. It's not a good predictor now. All right? So variables added last.
What was the difference between the R squared and the English and the R squared and the math?
0.12 and 0.17.
I forgot to look at the R squared here for
So
English.
English was even less explanatory.
What was it?
English was 0.12. And math
English was 0.12. So it was less. It's interesting to me that the math, when we had math in there by itself, wasn't its t statistic only 2 point something?
That was 5.68.
Oh, was it? Okay, maybe I was looking at the intercept one. But, because I was surprised that English came up to be 4 point something when I was remembering 2 point
Can we pull
something.
that one back up?
I don't know. Let's see if we can pull that one back up. Let me cancel this.
Maybe it was three up there up over your left shoulder.
On M, what'd you say over
Project tree.
right there?
That was,
There we go. So that.
that was
Nope.
3.
So number
Be that one?
I think
Ah.
it's
2? How come it's
No,
giving
look
me
at
code?
results, not
Oh,
code.
yeah. There we go. That one?
Again,
I keep bumping code, I think, with my finger.
Scroll up, maybe.
Nah, this is one I did before I came to class. I'm too far up on it. I can't get to it. I'm not smart enough.
I think it's over in the
I can't do it with my
project tree.
finger. Yeah, I can. If I look at this little window, I can remember what order I did things in better.
I think
So
you need to
under-
scroll up.
There's 3.
In that last window.
There it is.
Oh.
So here's high school math by itself. So it was, I was remembering the intercept, 2.6. So it's 5.63, right?
So would you say that one is even greater than English by itself?
By itself, it's a little better than English. I wouldn't say a lot, but it's a little better than English, right? So when you add all 3 of them in there, you get a model that went up to about 0.23 for R squared. So let's modify task again, and let's put all 6 of them, including the SAT scores. What'd you say?
It's gonna be 0.99 for R squared.
You think it'll be 0.99 for R
Probably
squared?
not that high.
0.7. Not even that.
Worthless. All 6 variables. The best we can do is 0.273. So we can explain 27% of the variability in college GPA. So what explains the other?
It could be.
What?
It could be a lot of variables that.
80.
Maybe your
73%?
teacher was right, that you can't get away with that crap in college. Stuff you do in high school.
Yeah. I mean, think about all the other things that explain why your GPA what it is. Right?
Hours of study time.
Yeah, I have a full-time job, so I don't get to study so much. Or I'm a terrible housekeeper, so I live in filth, and who knows? All kinds of weird things could happen. Corey?
Didn't you have the person's sex in that data set?
Yes, the person's sex is in that data set. That's right.
Is it not entered on the screen now?
I did not add it to here. I put 6 variables in. I have not entered sex yet. But
Probably done that for a reason.
no, well, I had done it for a reason because I wasn't ready to use. Remember, I talked about dummy variables,
The dummy variables, the 1
right?
and 0.
And it's set up as a 1-2 variable right now, which is fine. It still will work regression-wise in the same way. But so let's go ahead and add that and see what happens. I'm going to modify task. I keep forgetting I can do this over here. I'm going to take sex and add it as an explanatory variable and run.
Fair enough. But statistically speaking.
And then after it's in there, I want to take a look at all these p-values. Right? So now you're looking at,
Oh, that was
okay, so
That's good.
this is interesting. What happened?
So sex is explanatory for GPA.
Sex jumped the R square up to 0.2984. So we're up to about 30% of the variability explained.
Very
The
high.
2 was female, right?
What?
Because this one's 1 and 2, right?
Yeah, this is 1 and 2, and I don't remember. It'll be in your book, if you got your book. It will say which is males and which is females.
So if the average is like 1.5, then you have just as many males as females. That's
If the say it again.
if you average them together and the average is 1.5, you have an equal amount of males and females, right?
Yeah. That's probably true, but I need to find the beginning of this.
619.
Yeah, page 619, it starts, I'm now just skimming, looking for which is males and which is females. They don't really ever use the sex variable in this particular, it's left as a homework problem. So maybe that's where they explain which is which, but. But we can probably figure out which is which, right? Let's go to tasks and describe and summary statistics.
Whichever one has more is female.
Yeah, that's right. And we'll put GPA as our analysis variable. How come that didn't work?
Try again.
There you go. And then I'm going to take sex and put it as a classification variable. You can also do it and accomplish basically the same thing by doing it as group analysis by. So that's called a by variable. Do it by sex, then you get one analysis for males and one analysis for females. Right? But doing it as classification variable, just the only thing different, it makes the output look a little different, and I like that, looks better. Okay, so sex equal 1 has an average GPA of 2.78, and sex equal 2 is 2.93. So which one's female?
So
The better one.
Yes.
Which is pretty much usually the case, but I don't know for sure that that's the case here. But clearly there is a difference between the genders, and in the regression output, is that it? Do I have to double click? Hey, it worked. In the regression output, the p-value for sex is 0.0248, and remember that's variable added last. So that means that even after adjusting or holding fixed all of the 3 high school scores and the 3 SAT scores, then gender still explains a significant amount of the variability in GPA. Now, what do you notice about the p-values for the other 6 variables?
A lot of them are very high.
2 other ones that are significant.
Okay, starting with high school math, not significant. High school science,
Almost significant.
almost significant. So if I were choosing variables to leave in the model, then I would probably say, yeah, I want to keep science in there. So I relax this firm cutoff of 0.05. So then 0.6 for high school English,
So
don't
you
need it.
drop that, right?
I probably drop that out of the model. SAT math score. It's interesting that high school math grade is not significant, but of the 3 SATs, the math SAT part is the only one of the 3 that is significant. So if you tell me your high school science grade, you tell me your SAT math, and you tell me your gender,
You have a
I can
percent.
pretty well predict what your GPA is going to be. Well,
With like 25%.
yeah, I can do just about as good at predicting your college GPA as if you give me all those other things also.
So if you drop the really high p-values out of the model, would your R-square go up? Is that?
I don't know. Let's think about that. One of the things that you need to understand, and Taylor knows the answer to this question, anytime you add another variable to a model, even if that variable is generated by a random number generator, it doesn't have anything to do with your data set, you put another variable in, your R squared can never go down. So it's at least as big as it was. And with any real data set, it's going to go up a tiny bit, even for a bad variable. So the variable, or the model with all 7 variables, is going to have a higher R squared, 2984, than any model that I drop some out of. But the question is, if I drop some out and I stay at 0.28 something, maybe I say, oh, it's worth it. You know, you're not gaining enough by putting the extra variables in there to make it worth complicating the model. Okay. Corey had a question first.
I just kind of answered it. So you wouldn't really cut variables in an example like this with only 7 of them, would you?
No, you certainly would.
Even if it,
If the variables aren't doing you any good, what we always say you've heard of the KISS principle, right? Keep it simple, statistician. Yeah. So you want your model to be as simple as possible, but no simpler. Right? So think about all those test questions that I give you. And I said, give the predicted value of a model with 7 variables in it. It takes you longer to get that predicted value than if there's only 3 variables in it. And if the 3 variable prediction is really close and almost as good as the 7 variable prediction, then why not use that one?
Can we run one with the SAT math and sex?
Yes, we can run whatever you want. So
Just the SAT math and the sex.
Without this high school math 069? Or high school science?
I think it would probably be insignificant.
Okay, well, we can find out.
Is there a way to split it out by sex? So you can see two different sets of results, one for one and one for two?
You can do anything like that you ever want to do, right? So what his question was is a good one. I could take sex and put group analysis by, and I get a separate analysis for the two sex groups. So we can run that too. But let's take the high school science grade. Oh, I want to go the other way. I got everything in here, so let's start removing stuff. So high school math, take it out. High school English, take it out. And then SAT, critical reading and writing, take those out. And leave 3 variables in the model, right? And run. Pretty soon I'm going to fill up the buffer, but we'll see.
Really high R-squared stuff. Relative.
Okay, so the R squared is now 0.2829. And what was it before with all 7?
0.29.
2984.
But I think your adjusted R squared is pretty much the same.
Yes.
Yeah, and we haven't talked about adjusted R squared, and the book really doesn't. But adjusted R squared is a way of offsetting that little problem that I said a minute ago, where the R squared is guaranteed to go up even if the variable's worthless. Adjusted R squared won't necessarily go up. It can actually go back down. And so adjusted R squared is really better to look at. So now look at the variables in the model.
That's a good model.
That's a pretty good model. It's got almost as high of an R squared as you can get if you have all the variables possible. And everything in there is significant. So the high school science grade turned out to be significant now. Why was it borderline significant before, and now it's highly significant? What happened?
Probably the SAT science score was explaining some of it.
Okay, probably the SAT science score, which I removed from the model, was explaining some of the same variability. So now all of that variability falls to the high school science grade. And probably same thing true with, I took high school math out, and it was highly correlated with high school science. So same idea. Yeah.
So if you put like SAT science in, could it possibly be very significant by itself without the SAT math explaining it?
Yep, I could probably swap out those two.
And I
So-
was thinking about the high school math too. I wondered if it would go to the significance of the SAT math, even though it was less before, because this one was explaining it, it became less significant.
All right, so what you guys are getting at is, what if I put this variable in but take that one out? And what if I, right, that's model building. So guess what? SAS makes that reasonably easy for us to do. I can go back to my regression window, and I can put all 7 of them in there. So I need to add back in high school math. Let's see if I drag it. It's easier. High school math, high school English, SAT critical, SAT writing. I got them out of order from what we had before, but it doesn't matter. But then, rather than just hit run, I come up here to model in this left window, click on model, and then it says model selection method. Right? Now in 346 regression class, we learn a lot about all those model selection procedures. The only one we're going to deal with in here is the R squared selection method. And the only reason we're really not letting it choose the model for us, but it's a way of getting SAS to run all the possible combinations of the variables. And then we can look at, well, if I take this one out and put that one in, here's what the R squared is. And you can then decide, well, which one do I like the best? So right now it says no selection full model. So that's saying if you leave it like this, it's just going to put all the variables in there, and that's the one model it's going to run. But if you pick one of the model selection procedures, so you see choices, forward selection, backward, stepwise, maximum R-square improvement, minimum R-square improvement, and so on. And I'm just going to click R-square selection.
So why did you do that one instead of adjusted R squared?
Just because this book doesn't really talk about adjusted R-square that much, but in practice I probably would use adjusted R-square.
Do you use that more? This is probably a 346 question. Do you still use adjusted R squared more than when you use Mallow CP or?
No, I like Mallow CP and this Aki-Iki's information criteria. I like to see those too. I like to see all of them, right? And then I can make a judgment call. We won't talk about all those things in here, so we're just going to worry about the R-squared. But what this little window now is letting me do is pick what statistics do you want to see on your output in addition to the R-squared. So the selection procedure, that's telling it I want to see R-squared, but I want to see adjusted R-squared also. How come that's not doing anything? Let me try the mouse. I must have a bad finger. So I want to see that. I want to see the root mean squared error. What does that tell me?
Standard error.
Yeah, that's the standard error of the model. And I want to see error sum. I was looking for SSE, error sum of squares. I don't know why they use MSE, but then they spell out error sum of squares. So that's SSE, right? So you may or may not care about seeing all those things. Over here, you can play with some of these variables, but this window says effects to force into the model. So I'm letting the model select, or let SAS select the best model, but you can say, but I definitely want to have high school math in there. So then you force it into the model, right? So then every model you look at will have that one in it. But I'm not interested in doing that. So let's run it. And the output you get, this is what I cut and pasted over to that PowerPoint presentation because I can't explode this up, and this is hard to read. A lot of stuff here, right? So let me go over to the PowerPoint, and I've broken it into chunks. Let's do that. This is a look at the residual plot. I'm going to come back to this and some model diagnostics. So, actually, this is about the same size as that other one was, turned out. But on my screen, it looked a lot worse. But over here, it says model index. Hey, that was good. It jumped to the next slide, so that one I blew up a little bit. But let me go back to this one. So it has number in model. So that's number of variables in the model. So notice it's got 7, or I didn't use gender when I was doing this one. So I don't have gender, which now I should probably go back and look at it. But so I've got six different models that have one variable in them. And here is the R-square for each of those models. So, and they're ranked. So the best one variable model is always going to be at the top. The best two variable model at the top of the twos, and so on. See what you're reading here? Yeah. So the best one variable model has high school science. So if you're only allowed to use one variable, the best one to use is high school science. It's better than any of the others. Okay? Then if you go to two variable model, the best two variable model is line number 7, and it has an R-square of 0.25. So we jumped from 0.196 to 0.2538. That's a pretty big jump. So it's worth adding another variable to that model. So to high school science, we add SAT math. So now you can compare, okay, what if I added, instead of that one, I added one of the other variables, or I swapped out, all of the two variable models are listed here, and you can see all the combinations. And you can see how the R-square works. And there's a lot of two variable models that are awful close to the same, 0.22, 0.21, down to high 0.20s. But this one is quite a bit bigger, so you get a jump with that one. So it's a clear choice if you're going to use a two variable model. So the next slide has three variable models in it, and we jumped. The best three variable model is 0.2657. We went up from 2.5 something to 2.6 something. And now you're starting to say, that's not a huge jump. And it still had high school science in it. It still has SAT math, and they added high school math. So it's kind of interesting that high school math and SAT math are both in the best three variable model.
This is still, this doesn't have sex though, right?
Yeah, I didn't do it with SAS. So we'll go back. The SAS output behind this does have sex in it, so we can look at the same output. But so here's your 4 variable model, 5 variable model, and 6 variable model. The 6 variable model we've already seen with the R square of 0.273. That's the best you could do with all 6 of those variables. 4 variable model is 0.27. So remember, do you remember what the 3 variable model was?
0.26.
0.26, kind of high 0.26s, right? So I went up to 270 something. So not a big jump. And to get all the way to the full model, it's now 2730. So one of my favorite things to do on a test is to give you the full output like this and go, what model would you recommend and why? So you'd go for this 6 variable model.
Maybe. No, I'd probably go with the 4, the top 4.
Probably go for the 4.
Yeah.
And like I said, it's a judgment call. There is no definite right answer to these things, but you should think with the KISS principle in mind. Keep it as simple as you can. Don't add variables to the model that complicate it for no real benefit. Right? Let me get out of this and go back to the SAS.
What role does the sum of square error right there on the 6 is much lower than the one up there on the 4? What role does that play?
What?
Sum of square error right here on the 6.
Oh, sum of squared error.
Yeah. See how it's less than the one up there on the 4?
Yeah, he's looking at sum of squared error, so that the error sum of squares from the ANOVA table. With the 4 variable model, it's 72.67, and down here it's 72.46. Right? What happens to sum of squared error when you add another variable into the model? It can't go up, right? Adding another variable cannot add to the total amount of unexplained variability. So it's guaranteed to go down, but if you look at this number, 72.67 compared to 72.46, that's hardly any change. So adding 2 more variables after the 4 variable model did not decrease the error hardly at all.
And the 5 variable model is 72.47. So it's actually
The best, yeah, 72.47.
so it's a 0.2
Yeah.
drop.
So from there to there, that 6th variable did really nothing. But you did get a fair amount of drop from the best 4 to the best 5. So now let's look real quick at the SAS output that had sex in it.
Just talking about it.
So the best 1 variable model is still high school science, and as a 1 variable model, sex is the worst one. Because all it can really do, if you only have that 1 dummy variable in the model, all it can do is compare means. How's the mean for males compared to the mean GPA for females? And so it's not as good. 2 variable model, sex is way down there before it pops in the first time. 3 variable model. How do I scroll? Here we go. I'm going to go to the top of the 3s. There it is. So this line right here is the top of the 3s. And the best three variable model now has gender in it. So it's kind of interesting. After you control for science grade and SAT math score, now gender becomes important. Well, when you're a statistician, you have to learn enough about every area of science to understand why would that happen, and is that, I always say, biologically plausible, but it may not, it may be financial data, so biology is not the right word, but is it plausible in the field of study that that could happen? And if the answer is no, that makes no sense at all, then maybe I don't want to use that model, even though the statistics say, hey, this is the best one, but that makes no sense. So it's just spurious regression. So now let's look at 3 variable versus 4 variable. If I go to a 4 variable model, now I'm up to 2958, and sex is still in there. Notice it's this. Are these the same 3 that we had for when we didn't have sex?
No. Oh, yes. You
Yes,
just added
they
SAT math.
High school math, high school science, and SAT math?
Yeah.
Well, you had sex on 3.
No, I'm saying when we weren't considering
Yeah.
sex before we,
Math, science,
was that the best 3 variable model?
Yep.
Okay. So 4 variable model adds sex to that. The best 5 variable model is off the screen. Probably also has sex in it. Whoa. So best 5 variable model is this line, and our R square is 2733.
Sex.
I'm sorry, this is R square. It's the first column. 2977. And same other 3 variables with high school English added in, but that's hardly any increase. And to get to the very best possible model is the 7 variable model, which is 2984. So I would probably argue that the 3 variable model is close enough to the best to think that that model is the one I would go with. Right? 2829 as opposed to a max of 2984.
And doesn't that have the smallest sum squared errors?
Of the 3s,
We'll go down to the 4.
like the 7 had a,
Oh,
or a 69.
Oh, never mind.
Yeah, the sum squared error has to go down, just like R square has to go up. Remember how you get R squared from an ANOVA model. You take sum of squares model divided by sum of squares total. Well, sum of squares model is sum of squares total minus sum of squares error. So
So what's that?
you can argue that if R square goes up, SSE has to come down. Right, so the 7 variable model will have the lowest SSE of all of them, 69.9. That's the only one I saw that dropped below 70.
So going back to what you said about looking at it and choosing not to use that model, it could be financial situation, it could be living circumstances that the sex would be playing a part, but not necessarily a discriminator in ability for GPA. So in this case, would you, in the three variable model, would you throw out that one and go for the next one down?
Would I throw out sex
Yeah.
in the 3 variable model? And what I missed the first part of what you were saying.
You were saying that does it make sense? And I was thinking that it could be like financial, living circumstances. It could be a lot of hidden variables behind sex. So given that, would you throw that one out and go for the one below that?
Well, if I believed strongly what you just said, then yeah, maybe so. But no, I would tend to use this model that has sex in it. It's a pretty fair jump over the next best 3 variable model, and I think there are valid reasons why sex can explain GPA, right? So yeah, all those things, the difference between the sex. If I'm not interested in those things, then maybe I don't want it in the model. But I'm interested in predicting GPA, and sex seems to be an important predictor of that, so I would keep it in.
So I guess I'm confused what you were saying about the biological.
If it's biologically impossible for a man or a woman to be smarter than the other, you throw it out.
Yeah, if it makes no sense that sex would be a predictor, then what you're saying is, well, what I think then is that, yeah, the statistics popped it up as being significant, but it's probably just random chance. Remember, there's a 5% chance, alpha equal 0.05, that even when the null is true and there's no relationship, it'll show up significant in a sample of data. But if I took a different sample, it would go away. Then that's when I would kick it out.
So if there was like a variable that said like they wore blue when they went to
Yeah,
take
exactly.
the SAT,
Yeah.
even it may show up, but he's going to say that doesn't make any sense.
That was the exact example I was thinking of, by the way.
A blue
Blue
dress?
and yes.
Yeah. Well, that's a great example, though. Something that, there's no way that would then, if it shows up significant, you just chalk it up to one of those type 1 errors and you take it out.
What if you were using sex as a dummy variable?
That is using sex as
Yeah, that,
But we're still taking that into consideration.
that's the only way to enter a categorical variable into a regression model is as a dummy variable. And we haven't talked about dummy variables much for more than 2 levels. Well, I think I did, actually. If you have more than 2 levels, you have to have a dummy variable for all but one of those levels. We talked about that. And then this kind of a discussion gets really complicated. Like suppose I have race in here as a predictor, right? Well, I've got 4 races, so I have 3 dummy variables. What if the model picks one of them but not the other 2? I don't know. It gets complicated, so we won't go that deep into it in this class. But. Okay, the only thing I have left to do on multiple regression is I was going to demonstrate for you how to run the same model, not this selection procedure. Excel won't do that. But you can run a multiple regression model in Excel. So you can put in all 7 variables or whatever. So I will just send that out as some instructions in your homework set. Do this in Excel, do this in SAS. Okay? But you know how to do it in SAS, so I don't need to type those instructions up, but I will type them up for Excel. All right? So we will see you Friday. Yep.